Okay, this is our second video. The first one was pretty long, but equilibrium is so important. I really took my time with that one. This one's going to be quite a bit shorter. Okay, so this is what I call manipulating K expressions, equilibrium constant expressions. So when you have this, kind of goes back to Hess's law. If you remember Hess's law from last semester, you can flip reactions, you could do 1 over, all of this stuff. This is very different than enthalpy. So when you did delta H, the rules were very different. So I want to spend a little bit of time talking about how you can, if you have the K numerical value, the equilibrium constant, a number for one reaction, you can figure out what that number is for another reaction that is very similar. So if you can manipulate that first reaction by flipping it, or multiplying or dividing all the coefficients, you can get a K value for that new reaction. Let me show you what I mean. So let's start with an example. If we have, I like this one a lot, I use this example a lot, going between ozone, which is O3, to dioxygen gas. What's the K for that? I don't know. Oh, wait, but I'm given more information. Okay. If this, that looks like 30, but it's O for oxygen. What if the K for that is 1.8 times 10 to the minus 5? And these are unitless. They don't have any units. Oh, okay. So if I'm given that, what can I do to this equation can I manipulate this to get this one? If I had other terms like a carbon or carbon dioxide or helium, I couldn't do anything with that. But if I have all the same reactants and products and they're balanced in a similar fashion, I can figure out what that number is. So I'm going to call that K prime equals question mark. So I don't know what that is, but I can figure it out. But here's where it gets tricky. If you try to solve this like enthalpy last semester, it won't work. But you can just set up the K expression and compare it. So what did I do here? I just flipped it, right? This is flipped. So that means I switched the product side with the reactant side, right? I just went flip. I made the reactant the product and the product the reactant. The coefficients are the same. The formulas are the same, and the phases, I was too lazy to write that one, but the phase is the same. Now here's where students get confused. They'll want to make that negative, but K can never be negative. So delta H does not follow the same rules as K. So how do I know what this is? Well, I can tell you it's going to be 1 over K. But instead of memorizing that, how about I just show you how to solve the problem? I think that works really well. So if 1.8 times 10 to the minus 5 equals, I'm just going to set up my expression like this. And we are asked for, if I flipped it over, I'm going to write the equilibrium constant expression for both reactions, for the one where I'm given a number and the one that I'm asked to solve for the number. I'm going to compare these two, and how these two expressions are different is how I changed the number K. Not what I did to the reaction. It's the rules of writing the equilibrium constant expression. So how are these different? This is 1 over that bottom ratio. It's the inverse. The reciprocal, so it's 1 over 1.8 times 10 to the minus 5. Because these are reciprocal or inverse, I don't know, is that an A? I think it's an A. So the reciprocal slash inverse, if I compare two equilibrium constant expressions, whatever the difference in those expressions, whatever I do to one to get the other, that's what I do to the K value. So this is my new K value, whatever that is. Okay. So it is. It's different than delta H. So I want to do one more that's not on the slide. And then if you go to that Kahoot link, let me know if it's not working. That link looks a little funny because it has the create link on it. So let me know if that isn't, if you're not able to access that one. And Kahoot is just a little quiz for you to practice, and it's more fun than just a regular quiz. Okay, so let me do one more. I'm going to use an example that we had earlier. So let's say we have this reaction. This is one that we used earlier in the slides. And let's say at this temperature we have a K value of 5 times 10 to the third. And let's just say it's a Kc. And you are asked to find the Kc for this reaction. And pretty soon you're going to see how it is similar and how it is different. So you are asked to solve for that value. Now again, you're going to want to use your delta H rules from last semester, but they won't work. With delta H, when you multiply the reaction by 2, you multiply the enthalpy by 2, but that is not the correct answer. How do you know? It can be very confusing. How I do this is I write the two expressions and I compare them. That always works. So products of reactants, no, whoops, that's solid. No solids, no liquids. So I'm going to write the expression and then I'm going to look at what's different. So that's my first K value, 5 times 10 to the third. Okay, now let me write the expression for the second version and let's see how these are different. I'm going to write it over here. So that one is a solid, so I'm going to ignore that. So this is water to the fourth divided by this silane squared times dioxygen to the fourth. So I need a new number. The prime just means different. I didn't multiply these by 2 or I'd have a coefficient of 2 here. I'd have a coefficient. That's not how the equilibrium constant expression works. So now I think it's a little bit clear. What are we doing here? That's an understood one. We're actually squaring it, right? This times itself gives you this one. So we're actually squaring. So it's 5 times 10 to the third, and we're actually squaring that value. What always works, you can memorize a set of rules for K expressions. If you flip the reaction, it's 1 over the original K. If you multiply by every coefficient by a number, it's K, the original K, raised to that power that you multiplied. If you divide by a number, it's the square of that, or cube root if it were a 3. If you're dividing all of the coefficients by one number, it's that root of the original K. You can memorize that set of rules. Or, being electrocuted. Random cult favorite movie reference. Okay, so, or you can set up the expression, compare the expressions, and the only thing you have to know how to do for that is how to set up equilibrium constant expressions, which is really important. Okay, go ahead and try that Kahoot. If the link doesn't work, let me know and I can update that.